Hello. So this worksheet, or the two worksheets that we're going to do, are for graphing. So we're going to look at the coordinate plane and the definitions for these words over here. What I highly recommend is you taking this and trying to figure out if you can remember, or if you can't remember, then, for example, Googling the the definitions for these and to see if you're able to fill it out and then check it with, my answers. So pause the video and try filling it out on your own, and then check afterwards. So I'm going to start. So we're first looking at the coordinate plane. And plane has two number lines that intersect at a point. So this one is coordinate. Has two number lines that intersect at a point called the. So these are our number lines. These don't have the numbers, but normally you would have the numbers here. And the point that they intersect is called the origin. The horizontal number line is called, so this horizontal number line is called the x-axis. The vertical number line over here is called the y-axis. The two axes divide the coordinate plane into four parts called the quadrants. So here's, for example, one quadrant. And then there's 2, 3, and 4. The location of a point in the coordinate plane is given using an ordered pair of numbers. Oops, that goes here. The first number is the x coordinate. The second number is the y coordinate. So this ordered pair x and y, we would write them inside parentheses. So this is an ordered pair. The first number, 1 is an x and 7 is y. They are in alphabetical order if you struggle remembering which one's first. Okay, next we're going to look at equations in two variables. So for an equation with two variables, x and y, a pair of values x, y that make the equation true is called a solution. Of the equation. Each solution is an ordered pair. This here is an ordered pair. So each solution is an ordered pair. The value of x is written, again, the value of x is written first. The value of y is written second. Where's my second? Each solution can be represented as a point in the coordinate plane. So here's our coordinate plane, and we can, present it as a point. And this would be, if all of these were ones, this would be 1, 2, so that would be negative 2, and then 1, 2, 2. So that point would be negative 2, 2. The set of all points representing solutions is called the graph of the equation. An equation in two variables has an infinite number of solutions. So there is an infinite number of points in the graph. So equations in two variables means that we have x and y. X and y are the variables. Normally you could use other letters as well. Variable means that something that doesn't have a set value. Like 1 and 7 would be a set value. Those are not variables. That's why we use letters, because they vary. Okay, next we're going to look at linear equations in two variables. So if the graph of an equation in two variables is a straight line, the equation is a linear equation. That word has the word line in it. Straight line, line, AR, linear equation. Every solution can be represented by a point on the line. So these solutions are points on this line. For example, the equation y equals 2x plus 5. This is a linear equation in two variables. We have a y and we have an x. Is a linear equation because its graph is a line. One solution of this equation is, now, here's a tricky part. So we have two different points here. We need to figure out which point is a solution for this particular line. So what we're going to do is we're going to go ahead and substitute. So we have y equals 2x plus 5. And let's try the point 311. So for the point 311, 3 is x and 11 is y. So 11, instead of y, we're going to write 11 equals 2 times 3. Remember, there's a multiplication in between, plus 5. So 11, 2 times 3 is 6 plus 5. 11 equals 11. So this is true. So this point is a solution of this equation. If we didn't get the left and the right to equal, then it would not be a solution. 2x plus 3y equals 90 is a linear equation because its graph is a line. In a linear equation, the highest power of either variable is the first power. So now what you want to do is, of course, put those letters here and see why was the baby confused. Okay, next page here is going to be a scatter plot. So we're going to construct a scatter plot for each set of data. We're actually going to only do this top one here and describe what kind of relationship, if any, is shown. So what we're going to do here is I'm going to grab actually a piece of paper so that I can keep myself kind of straight here on the correct lines. So first we're going to look at this I mean, basically this is a coordinate plane as well. We just only have the first quadrant here because these are positives. We don't need the others because, of course, when we're talking about fat and calories, we're not going to, and food items, we're not going to have negative fat. grams or negative calories on it. So that's why we're only in the positive quadrant of the coordinate plane. So our x-axis here, so this is our x as always, is fat in grams, and our y-axis is the calories. So what I'm going to do is I'm going to look at a hamburger, and notice fat is 9 grams. So 9, okay, so we have a 10 here, we have 1 between. So this has to be a 5. What I can do is do 10 divided by 2 equals 5. This has to be 20 and 10. In between, halfway between, is a 15. So that has to be a 15. So this is 25 and that is 35. Over here, we have a 0 and 100. So halfway between that is a 50. And halfway between 100 and 200 is 150. 250 and 350. 450 and 550. Okay, so now let's start graphing. 9 grams. Well, 9 is between 5 and 10. It's closer to 10. 260 calories. Well, that's 250 right here. So we're going to go a little bit above that and very close to the 10. That is our first point. Our second one is 13 cheeseburger, 13 and 320. Well, 13 is going to be closer to 15, but not. There's a 14 between. And 320. So there's 300 and there's 350. So it's somewhere here. We can't really do a totally accurate one with these numbers and these coordinates, or the way this is drawn. We can kind of put it somewhere close to it. Same thing, 31. That is between 30 and 35, close to 31. And we go all the way up to 560, which is above 550. Next one, 21 and 420. So that is to the right of 20. And then 420 would be almost halfway. 34 is right to the left of 35, and 590 is almost to 600. 20 and 440, well, 20, and then 440 is right below 450. Of course, the 20 we can do accurately because that is right on the line. 22 is again going to be somewhere almost halfway, and 450 is on that line. 26, so that's going to be on the right side of 25, and 430 is somewhere here. We can't really. 0 and 35. So 0 and then calories 35. Well, that's not even 50, so it's somewhere here. 2 and 120. 2 is somewhere here, and 120 is, I would put it somewhere here. 21 and 230. So 21 and 200, and then 30 is somewhere in between. 12 and 290. So 12 and 290 is somewhere here. 23 is between these two, and 360. 37 is between these two, and 440. 8 and 130 is somewhere here. 3 and 300 is about here. 9 and 360, 300, 350, 360. 13 and 260 is somewhere here. And there are all the values that we've put in. So now we would need to see if there is a relationship. So the way you're gonna kind of try to figure it out is that you're going to take and draw a straight line through here and see if there is or if there's not. Of course, there's going to be exceptions, and the straight line is not, it's hard to draw a straight line. And now we can see that there's not, like, there's only a couple of points that are right on it. But we can kind of see that the more fat there is, the higher the calories. There's a couple of exceptions. Like, which one? What was this? Was it the baked apple pie? Well, that has a high sugar content. It doesn't necessarily have a ton of fat. Same with the shake and the muffin. They have other stuff that creates the calories, but more than likely, there's, the more fat, the higher the calories are, especially, up here. So that is how we draw a scatter plot, and we're going to be doing a couple of these. But this should help you with the 6.10 functions lesson. And again, if you have any questions at any point, please don't hesitate to ask. Bye.